Back with the second example involving the first derivative test. Different function this time. Let g of x be equal to x times e to the x. Okay, we have a product here, x times e to the x. Our goal is to figure out for what value or values of x does g have a relative min. Okay, a relative min. Well, a relative min for a function occurs when the derivative of the function changes from, yes, negative to positive. So we're going to do this whole sign chart thing again, but we're just going to look at a different part of the chart now. Okay, so here we go. Same steps as before. Step one, get our derivative. We have to define g prime. We have to find the derivative of x e to the x. Which rule should we use to get g prime? Okay, hopefully you picked product rule, and that would be correct. So here we go. G prime of x. We're going to derive the first. The derivative of x is 1, which I'm not going to write. And then times e to the x. Plus, now we keep the x and we take the derivative of the second. We take the derivative of e to the x. We know the derivative of e to the x is e to the x. Okay, so this is our g prime. This is our first derivative. We are interested when this derivative is equal to 0. That's our second step. Set the derivative equal to 0 so that we can find our critical numbers. Critical numbers occur when this derivative does not exist or when the derivative is equal to 0. Well, e to the x always exists, all right? It doesn't matter. There's no breaks, jumps, holes, any discontinuities, anything like that, vertical asymptotes. We're good to go here. So really, we just need to figure out when this function, if at all, equals 0. Okay, well, we have two terms. They're being added together, and we have to set them equal to 0. How do we go about this? We should factor, yes, okay? So we're going to factor out what's in common. What do these two terms have in common? Exactly, e to the x. So we factor out e to the x. All right, if I pull e to the x out, I am left with 1. E to the x divided by e to the x is 1. Plus x e to the x divided by e to the x is just x. And that's equal to 0. Okay, that's good. We have a product which is equal to 0. Whenever we have a product which is equal to 0, we just look at the two parts and see what, if any times, what values of x cause each of these parts to be equal to 0. Okay, so if we cover up the first part there, we have 1 plus x is equal to 0. I think you would all agree with me that x could be equal to negative 1. Okay, there's a critical number because negative 1 plus 1 obviously equals 0. Now we cover up the second part. We have e to the x is equal to 0. When does e to the x equal 0? That was a trick question. It never equals 0. E to the x, remember, that's our graph that goes up like so. Okay, but it never reaches the x-axis no matter which way we go. The graph of e to the x is always above the x-axis. E to the x is always positive. Never equal to 0. This is our only critical number. Okay, so now what do? We take our critical number and we're going to toss it onto a number line. All right, so here we go. There's negative 1. And we're going to pick some test values. Some values to the left and some values to the right. Now just be careful, okay, because I've seen students do something like this before. Negative 1. Okay, so I'm going to pick 0 and 2. All right, and they write something like that down. Okay, and realize now that they've actually picked two values which are bigger than negative 1. 0 and 2 both belong on this side of the number line. So when you pick your test values, it doesn't matter where in the interval you pick the test value, just make sure you do pick a value from the appropriate interval. We could put the 0 over here, that's fine, but over here we need something that's less than negative 1. Let's go with negative 2. All right, so now we're good to go. We have negative 2 and 0. Those are our two test values. We're going to take those test values and plug them into which function? The original function or the first derivative? Yeah, the first derivative because it's the first derivative test. Okay, so we're going to plug negative 2 and 0 into the first derivative. We want g prime of negative 2 and we want g prime of 0. All right, so here we go. We're going to take negative 2 and we're going to plug it in for x here and here. Remember, you can plug it into any form you want to, but usually the simplified form is the best one to choose. All right, so we've got e to the negative 2. Well, what did we just say about e? E is always positive, right? So it doesn't matter what number we plug in, we're going to get a positive result right there. E is always positive, no matter what its exponent is. Okay, then we're going to plug negative 2 in for x here. 1 plus negative 2, that is definitely negative. So we have a positive value times a negative value when we plug in negative 2 for x. All right, positive times a negative is negative, yes. So g prime of negative 2, that's going to be less than 0, so we can put a minus sign right there. Okay. Now we're going to plug in 0. That's our other test value. Well, I don't need to plug 0 into e because I know that e is always positive, but I do have to plug 0 in for this x. All right, 1 plus 0, that's definitely positive. Positive times a positive is a positive, so that means that we are above the x-axis. We are positive right there. Okay? Now again, this sign chart gives us a little bit of an idea of our graph. We're going to have a graph which is decreasing, and then it's going to be increasing because the derivative is negative and then the derivative is positive. So not only does this sign chart give us an idea of decreasing, increasing, well, it also tells us about relative maxes and mins. Notice right here, we can clearly see we have a relative min right at -1. And it's true because the derivative changed from negative to positive. So now we can answer our question. When does G have a relative min? Well, G has a relative min. G has a relative min at x equals -1. And again, the reason is important because G prime changes from negative to positive at this value. Okay? And we've answered the question. We've given the appropriate value of x as well as the corresponding reason.